So first you need to read the problem and identify the claim. So you can write it in symbolic form using the equal, the not equal, the less than, or the greater than symbol. And once you write the claim, you can write the null hypothesis and the alternative. So the claim is that the proportion of people that oppose to replacing $1 bills with $1 coins is less than 0.77. So we need to write it in the alternative. So the null hypothesis will be equals to 0.77. We have a left tail test, so the critical value will be positive or negative. It will be negative. For left tail test, the critical value will be negative because it will be to the left of 0. This will be the critical region, the rejection region for a left tail test. So what's the value of alpha that we're going to use? In table F, 0.01. So where do we find for 0.01? Where it says one tail or two tails alpha? One tail because it's a left tail test. So one tail, alpha 0.01, last row. So 2.326. So what will be the critical value in this example? In the table, we always have positive numbers, but if the test is left tail, we need to put the minus sign in front. So it will be negative 2.326. So now we can find the test value using the formula for Z. So what's the value of P hat? What's the proportion in the sample that oppose to the change? Now is when we use the information from the sample. It says the statistician selected a sample of 80 people and found that 55 were opposed to the change. So what's the value of P hat? 55 over 80. In decimals, that is 0.6875. So let's not round yet because this is an intermediate step. So we're gonna use, you can use the 4 decimal places, 0.6875 minus, what's the value of P in the null hypothesis? 0.77 over the square root of P, 0.77 times Q. What's the value of Q? 0.23. 1 minus 0.77. That's 0.23. And then divided by the sample size. What's the sample size? 80. So use your calculator. What's the value of Z that you obtain? Let's round it to 2 decimals. negative 1.75. Very good. So negative, because 0.6875 minus 0.77 is a negative number. The denominator is always positive, so negative divided by positive is negative. The decision is that we fail to reject the null hypothesis because the test value falls in the non-rejection region. Negative 1.75, so this number, negative 1.75, is here in the left side. Sorry, in the right side of negative 2.326. Because 0 is in the center, then we have negative 1, then we have negative 1.75, and then we have negative 2.326. So this is in the non-rejection region. That's why the decision is that we fail to reject the null hypothesis. So now we can write the conclusion using the information about the decision and the claim. The claim was in the alternative. P less than 0.77 is the claim. So what can we say about the claim? We fail to reject the null hypothesis. So we cannot reject the null hypothesis. So can we support the claim or not? What do you think? Very good. We cannot support the claim because the claim is the alternative in this example. And we fail to reject the null hypothesis. We cannot reject the null hypothesis. So if we cannot reject this one, it means like we have to stay with this one. We cannot support the alternative. We cannot support the claim. So there is not enough evidence to support the claim. Because we couldn't reject the null hypothesis, then we cannot support the alternative. So you have the solution, the hypothesis, the critical value, the test value, the decision. Do not reject. Here in this graph, you can see better that in mind that negative 1.75 falls in the non-rejection region. So there is not enough evidence to reject the null hypothesis, so we cannot support the claim that less than 77% of the population oppose replacing $1 bills with $1 coins.